Alright, so problem 2 from the pre-calc exam asks us to find a, b, and c when a, b, and c represent the exponents of x, y, and z in this expression. As you can see, this looks like a pretty complicated expression, but the fun thing about exponents is they're really easy to manipulate. The first thing that I want to do, just to get you guys to visualize this, is I'm going to assign a color to each variable, each base variable that's x, y, and z. And my hope is that by the end of our manipulation of these exponents, you'll be able to see exactly what c, b, and a are, because they will be lined up perfectly with the 3 different colors. So I'll have z in red. Now, to start, I would like to start with the outside exponent. Now, to review, when you're doing exponents, let's say you have an exponent with a base r to the power of 2, and that whole expression is to the power of -1. Well, this can be expressed as r to the power of -2, because you can just multiply these two exponents together when one exponent is being taken to the power of another. That's the same as r being taken to the power of -2. And what does it mean when you take something to the negative power? Well, that's the same as saying 1 over that to the positive version of that power. So if it was r to the -2, it becomes 1 over r to the positive 2. That's the general principle that we're going to be using when we deal with this first exponent, this big -3, which is taking into account every bit of activity on the inside of the parentheses. So, first we're going to have to flip this and multiply the exponents in the top by 3 and the exponents in the bottom by 3. So when we flip it, what do we get? Well, this expression becomes the numerator. So that's z squared, and this is a -3 here, x, y. So you see I've taken this denominator and I've brought it to the top, and I'm taking the whole thing to the 3rd power. Then we're also going to do the same thing with the numerator. So we're going to bring it to the denominator. So that's y, x, z, to the 4th power, to the 6th power, and to the -2 power. And these expressions are equal. So, what happens now that we have this power of 3 on the outside? Well, we're going to multiply every exponent on the inside by 3. So, we end up with -9. 3 times -3 is -9. And 3 times 2 is 6. Let's fill in those exponents. Those base values. And that is all over. So we distribute the 3 into these exponents as well. 3 times 4 is 12. 3 times 6 is 18. And 3 times -2 is -6. Z to the power of -6. X to the power of 12. Y to the power of 18. Now, if we combine like terms, notice, for instance, in this situation with the z, we've got a 6 up here and a -6 down here. Let's just rewrite this one isolated chunk, or let's use another example. So let's say we had base r to the power of 3 all over base r to the power of -2. Well, if we wanted to bring this thing from the denominator up to the numerator, that's just like before. It's the same as saying times r to the -2. And what happens when you have an exponent, or rather the same base with 2 different exponents and they're multiplied together? You just add the exponents, because this is the same thing as saying r times r times r, that's r cubed, times r, that's r squared. These two cancel and become positive. So this all equals r to the 5th. just as an example. So in our situation, ha, we're going to have this z here, and if we wanted to bring everything up to the numerator, this would be the same as 6 minus, because we're bringing this up to the top, a negative 6. And while we're in this step, let's also distribute this negative 9. If you have this exponent being applied to both x and y, well, that's the same as saying y to the negative 9 times x to the negative 9. And this is going to be all over x to the 12th and y to the 18th. So, that is equal to the following expression. We can add these two together into one number, so 6 minus a negative 6 is 12. It's the same as 6 plus 6. And then let's bring these two up to the numerator. So we're going to have this, if we brought it up to the numerator, would be a negative 12. So what we have here is x to the power of negative 9 minus 12. And we have a y here with a power of 9 minus 18. So, in the end, this is now all over 1, just because we brought both of these up as well, and all that's left in the bottom is a 1. You could even say there's a 1 multiplied in the front here. It doesn't matter. So, finally, we've got one x term, one y term, and one z term. And what are their exponents? Well, z is to the 12th power, y is to the negative 9 minus 18th power. That's negative 9 plus 18. So that is 27. And x is to the negative 9 minus 12 power, which is the same as negative 21. So, now we can say that, let's see, a equals negative 21, b equals negative 27, and z equals 12. And that, my friends, is our answer.